Today we're going to talk about an extension of the law of sines, and it's called the ambiguous case. Now, the ambiguous case arises when we have two sides given and an angle. So we call that SSA, where you have two sides and an angle. And the reason it's called the ambiguous case is because it's possible that two triangles could exist with the given information, or that no triangles exist with the given information. And that's because if we take the inverse sine of an angle, we know that we could have two possible solutions. For example, if I said the sine of theta is equal to 1/2, okay, we know on the unit circle that sine is equal to 1/2 at 30 degrees and 150 degrees. So if we get this equation right here through our law of sines, then we know that there's two possible angles. Notice that is different than saying the inverse sine of theta, the inverse sine of 1/2. That's different than saying that, because the inverse sine function has a restricted domain. The normal sine function does not. So we're going to be using the law of sines still, but we're going to be solving for an angle. There are some things that you should be on the lookout for. You always want to draw a triangle and then label the information given. And then we're going to create a table with two possible triangles and fill in all the missing parts. When we calculate the inverse sine, that means we have two possible angles. So some people get confused and say, well, how do I know if this is the ambiguous case or not? Anytime you are using the inverse sine function to solve using the law of sines, this is going to be the ambiguous case. Then you're going to solve the other parts of the triangle and see if it makes sense. So you're going to solve both triangles and then go back and see, does this triangle exist? And we could have 0, 1, or 2 triangles. To determine if a triangle exists, okay, make sure all angles add up to 180 degrees. If the angle that's given to you is bigger than 90, then we know two triangles can exist. If we end up taking the inverse sine of a number bigger than 1, that means the triangle doesn't exist. It'll give us an error in the calculator. And then finally, the largest side should be opposite from the largest angle, and the smallest side should be opposite to the smallest angle. And we've talked about those things before, and now we're going to be applying them. So here we have solve triangle ABC. So let's draw triangle ABC. We know big A is 94 degrees. Little a, so the side across from A is 18, and little c, the side across from C, is 13. Now, you may remember that I just said if our angle given to us is bigger than 90, then there's only one triangle. I'm still going to show two triangles in this one, just for you to see what I was talking about. All right, so we're going to do the law of sines. We're going to say we're going to say 18 over sine of 94 is equal to 13 over the sine of C. So then we cross multiply just like what we did the other day, and we're going to have 13 times the sine of 94 equals 18 times the sine of angle C. Divide both sides by 18. So then in my calculator, and again, we want to make sure we're in degrees. Thirteen times the sine of 13 times the sine of 94, close parentheses, divided by 18. Change my mode to degrees. and we get 0.72. So 0.72 equals sine of C. So then we have to do the inverse sine of 0.72. So inverse sine of 0.72 equals 46.05. So we're just going to round to the nearest degree, 46 degrees. So over here, we're going to make a table of two triangles and the missing information that we have for each of them. We have triangle 1, triangle 2, and we are trying to find angle C. We are trying to find angle B, and we're trying to find side B. Okay. So angle C in one triangle, we got 46 degrees. Now to get the other triangle, we need to do 180 minus 46. And that gives us 134. And these two should add up to 180. Now, if our second angle is 134 and the angle that we are already given is 94, well, that's already over 180. So we can't have a second triangle. And just to verify, if we did 180 minus 94, minus 94 minus 134, we get negative 48 degrees. That doesn't make sense. So we know that there's only one triangle here. So now we need to figure out angle B. So we know that the angle given was 94, and we figured out the other one was 46 degrees. So if we type this into our calculator, 180 minus 94 minus 46, we get 40. So our remaining angle must be 40 degrees. Okay, now we can find side B, as we have B over the sine of 40 degrees equals, I'm going to use this information that was given to us, so 18 over the sine of 94. So let me cross multiply. So we have 18 times the sine of 40 degrees equals B times the sine of 94. And then like we did yesterday, divide both sides by the sine of 94. So 18 times sine of 40, close parentheses, divided by sine of 94. And we get 11.598, so 11.6. 11.6. All right, so now let's go back and verify the information. Angle B is the smallest angle, and side B is the smallest side. All right, so far so good. Angle A is the largest angle, and side A is the largest side. So we have one triangle, and it works out. All right, for this problem, let's start off by drawing triangle ABC. And then we have angle A is 77 degrees, side A is 6.1, and side B, so the side across from B, is 9. So we're going to set up our law of sines. 6.1 over the sine of 77 is equal to 9 over the sine of angle B. So then we'll cross multiply. 9 times the sine of 77 equals 6.1 times the sine of B. divide both sides by 6.1. And when we do that, we have 9 times the sine of 77. Make sure you close your parentheses, divided by 6.1. And we get 1.44. So 1.44 equals the sine of b. Now, if you forgot that I said that if you have to take the inverse sine of a number bigger than 1, that the triangle doesn't exist, if we do second sine, so inverse sine of 1.44, see, we get an error because we can't get a number bigger than 1 and take the inverse sine of it. This part right here, because this is bigger than 1, we can't calculate that angle. So this one has no triangles at all. All right, now this one, triangle ABC, angle A is 30 degrees, side A is 10, side B is 15. So let's do the law of sines. So 10 over the sine of 30 degrees is equal to 15 over the sine of B. Cross multiply. 15 times the sine of 30 equals 10 times the sine of B. And then we divide both sides by 10. 15 times the sine of 30 divided by 10, we get 0.75. So then the inverse sine of 0.75 is 48.5. So we're going to round up to 49 degrees. Okay, so now what I'm going to do is I'm going to go over here and make that table for our two triangles. So you have triangle 1, triangle 2, and the information we are figuring out is we're figuring out angle B, angle C, and side C. Well, we figured out that angle B was 49 degrees, but in the second triangle, it's going to be 180 minus 49. So 180 minus 49 gives us 131. Okay? 131. Well, that's still okay because our angle A was 30 degrees. So now let's figure out angle C for both triangles. So if we do 180 minus 49 minus 30, that gives us 101 degrees. Then for triangle 2, we're going to do 180 minus 131 minus 30. And that gives us 19 degrees. So now we got to do the law of sines 2 more times, one for each triangle, to figure out what side C is. All right, so then over here, I'm going to do 10 over the sine of 30 degrees equals C, because we need to figure out what side C is, over the sine of, and I'm going to work in triangle 1 first, so that's going to be 101. Now we're going to cross multiply, so it's going to be 10 times the sine of 101 degrees equals C times the sine of 30 degrees. Divide both sides by the sine of 30 degrees. So 10 times the sine of 101 divided by the sine of 30, and we get 19.663. So 19.63 is C. So going back over to my table, now we have to look at the second triangle. Now, the second triangle, it's going to be set up exactly like this, but instead of this 101, it's going to be 19. So if you wanted to do a shortcut and just say, oh, I know it's going to look like this at the end, but instead of 101, it's going to be 19, you could do that, or you can set up the law of sines again. So we have our given side, 10 over sine of 30 equals C over the sine of 19 degrees. Cross multiply, so 10 times the sine of 19 degrees equals C times the sine of 30. Divide both sides by the sine of 30. So 10, we're going to type all that into the calculator. Whoops. So 10 times the sine of 19, close parentheses, divided by the sine of 30. And we get 6.51. So now we got to go back and just make sure everything makes sense. In triangle 1, the smallest angle is angle A at 30 degrees. The smallest side is side A at 10. The largest angle is angle C at 101 degrees. The largest side is side C at 19.63. Triangle 2, angle B is the largest at 131 degrees. Side B is the largest at 15. Angle C is the smallest angle at 19 degrees, and side C is the smallest side at 6.51. So this triangle, this situation does have two triangles that both are possible solutions. All right, now with this example, let's draw a triangle ABC. Angle B is 61 degrees, side B is 32, and side A is 35. So 32 over sine of 61 is equal to 35 over the sine of A. So cross multiply, we get 32 times the sine of A equals 35 times sine of 61. Divide both sides by 32. So then in the calculator, 35 times sine of 61 divided by 32, we get 0.956, so 0.96. So the sine of A is equal to 0.96. So then we're going to do the inverse sine of 0.96. Inverse sine of 0.96. And we get 73.7 degrees, so we're going to say 74. Okay, so now we're going to go make our chart over here. Triangle 1, triangle 2, and then we are figuring out angle A, angle C, and side C. So angle A we calculated in one triangle to be 74 degrees. So then we need to do 180 minus 74, and that will get us 106. 180 minus 74 gives us 106. And then we can figure out what angle C will be in both triangles. So 180 minus 61 minus 74, 180 minus 61 minus 74 gives us 45 degrees. Then 180 minus 61 minus 106, that gives us 13 degrees. Whoops. So 13. So now we're going to do the law of sines for both possibilities. 35 over this, oops, sorry, not 35. 32 over the sine of 61 equals, we're trying to find side C, so C over the sine, and in the first triangle, it's 45. Okay, so then we'll cross multiply. 32 times the sine of 45 equals C times the sine of 61. Divide both sides by the sine of 61. So 32 times the sine of 45 divided by sine of 61. We get 25.87. So 25.87. All right, so now we're going to do, again, with the other triangles. So 32 over the sine of 61 equals, we don't know what C is, but we know that the angle is 13. Cross multiply, 32 times the sine of 13 equals C times the sine of 61. So in my calculator, look, I'm just going to go back up and grab this right here, because the only thing that's changing is instead of this being 45, it's 13. We're still dividing by sine of 61. We get 8.23. 8.23. All right, so let's double check. All our angles do add up to 180 in both triangles. In the first triangle, the biggest side is side A, and the biggest angle is angle A, 74 degrees. In the second triangle, our biggest angle is also angle A at 106 degrees, and the biggest side is 35. And then the smallest angle in both triangles ends up being angle C, and the smallest side in both triangles is also side C. So this triangle does exist. Okay, this one here, then A, B, C. Angle B is 100 degrees. Side B is 29, and side A is 33. So I'm going to go through this setup, but I'm also going to show you, again, a reason how you, or a way that you know that from this problem, I can tell that there's going to be no possible triangles just from the beginning. So we'll cross multiply. We'll have 33 times the sine of 100 equals 29 times the sine of A. Divide both sides by 29. So 33 times the sine of 100 divided by 29, and we get 1.12, which is again bigger than 1, so no triangles. Now, I was able to look at this and tell beforehand because the angle we were given was bigger than 90. Okay? Now, in the notes, or up above, I said if the angle that's given is bigger than 90, then there can't be two triangles. There could be one. But we also know that the largest angle should be across from the largest side. Well, if that's the case, then that means the angle that goes with side A, so angle A, would have to be bigger than 100 degrees. And now we're over the 180 degrees that a triangle has to add up to. So you could have done it that way, or the math works out as well. All right, so just make sure that you are careful when you're setting up your law of sines and that you're creating the table when you need to, and then double checking if everything makes sense. So thanks for watching the video. Make sure to like it and subscribe.